Hello again. All right, welcome back. Today we're going to solve a long question. It's about exponential function and differentiate the exponential function, and also solving the exponential equations. Before we doing that, please remember to subscribe the channel, and so you don't want to miss any updates. And also provide your support. It does take a effort to produce all the videos. So if you can show your appreciation. Sorry, the noise outside. Okay. So if you can just give us the support, please. All right, we're going to start working on this question. So we got a gx, function gx, which is a cubic function. So we know it's here I can write down the function into this format. Y equal to, I'm going to actually using red pen, gx, I can write down into x minus k, cubic roots. Remember, always turn to a index, so it can be easily to differentiate. All right, let's do the question A first. Find the coordinates of P. In terms of P, what's a P? P is a y-intercept of the graph. So what is y-intercept? We know when the x equal to 0, so we want to find that g0 equal to what? So that's pretty simple. We substitute 0 into the function. So the answer will be y-intercept is 0, x is 0, y is m minus cubic root k. So we've done that. Easy for question A. Question B, find the gradient of P. So point P. So which means find a gradient at y-intercept in terms of k. So let's do that. Gradient means you find a derivative of g when x equal to 0. So let's find a derivative first. So we turn to index. The derivative of that is 1/3. Then remember, this has become 1/3 take 1 becomes negative 2/3. So substitute 0 into the equation, so we will get the equation which is g0, derivative g when x to 0. So let's do question C. Okay, given the graph passed through origin, so I express k in terms of m. So let's have a look at what is passing in. So this means when the x equal to 0, y is 0. So g0 is 0. So we substitute into the original function, we will get this. So we solve for k in terms of m. So we k to the power 1/3 is m. So we both sides, remember, if I both sides to the power 3, so the answer k is m to the power 3. So we use index law. Question C is done. The last question is a little bit difficult. So we discuss, we got two gradients points. One is P. P already know is at 0 at the y-intercept. Then the other point is Q. The both gradient are equal, so which is very important. So P and Q are gradient equal. So at the Q, I'm going to differentiate. We don't know what so we need to find the coordinates of point P, Q, sorry. So let's do that. So at the point Q, I'm using derivative function. So we do the differentiation, but at point P, we already done that. So therefore, because we know the gx equal to, we want to solve for equation. So gx equal to derivative gx equal to derivative g at 0. So therefore, those two equations equal. So let's solve that. So how do I solve? I'll cancel 3 out, so cancel 3 out. So first we take a 3 out, then we multiply by 3 both sides using index law. So we get -2, -2 on top. Then we can change times by -1 both sides, become positive. So when you do positive, so you don't need a negative, so become x squared. So then we take square root, positive and negative k. So we got 1 is a 0, which is already down at the p. So at the q is x to 2k. So therefore, the x 2k means k we want to write into in terms of m. So k is m cubed, so 2 times by m cubed. So x is that. Now, need to find the y. So how do you find the y? We substitute 2k into the original function g. So 2k minus k is 1k to the power of 1/3 m. So then replace k with m to the power 3. So m plus m to the power 3 to the power 1/3. So cancel that, become m to the power 1. So m plus m, well, the answer is 2m. So the answer, the coordinate for Q, point Q is 2m to the power 3 and the y is 2m. So now we solve for the coordinates of point Q. All right, thank you for watching. Please give us thumbs up and I'll see you next time. Bye.